Today's lesson is lesson 2.5, and we are going to be graphing special functions. For now, we're going to only cover two of the three special functions that are identified in my objectives. And I'm going to save the step function, the greatest integer function, for a later lesson. But for today, we're going to focus on these functions we call piecewise defined functions. And then we're going to do a little review of the absolute value functions. We've touched on those a little bit early on, but I will do a review with you on what those look like. But most of our lesson today will be centered around these piecewise defined functions. And here's a good example. If you're wondering what that means, think of it as a single function. You can see I have a single f of x, but it is broken up into three, in this case, three different pieces. And so our job is to graph this, and many times these pieces do not connect, and that can be typical of these piecewise defined. So I want to show you, first of all, how to sketch the graph, in particular paying attention to these limitations on the domain. Okay, we call this restricting the domain for these functions, and what is that going to mean? So I think I'll just color code, and if it helps, and this says f of x equals -1, and I hope you're getting used to the idea of really f of x equals -1 is the same equation. It really is another way of saying y equals -1. Maybe you're used to graphing the line represented by this equation, and you may not realize that really it's the same line here. It's just another way of representing it using function notation instead of just linear equation form. But in any case, whatever you have to do, you might want to lift these out one at a time. And I think I'm going to go ahead, and I did this in class some, and I think it helped a little bit. I'm going to go ahead and draw this entire line, y equals -1, or f of x equals -1, and without the restriction. And then maybe then we'll go back and add the restriction to fix the way the line should look. Okay, so if I'd ask you to draw the line y equals -1, I hope that you would grab your ruler and you would draw a horizontal line passing through or crossing the y-axis at -1. Easy enough. But this function doesn't say just graph y equals -1. It placed a limit on what the domain can be. Now, if you're wondering what does domain mean, well, associate that with the x coordinate of an ordered pair. So in other words, you can think of it this way. Any ordered pair has to contain an x coordinate that is less than or equal to 0. Well, that rules out certain ordered pairs like this one. This has an ordered pair of 3, -1. Well, 3 doesn't fit in this restricted domain, so we can't allow that ordered pair. Any of these ordered pairs, I'll just throw a couple examples. This is the ordered pair 8, -1. Well, obviously 8 doesn't fit this description either. So in general, none of the numbers that are to the right of x equals 0, which is the y-axis, will fit in this domain restriction. So what we're going to have to do, since we can't have any x-coordinates that are not described in this way, we're going to have to change our line. And so we need to cut off the line. Sorry about that. We need to cut this line off to show the domain numbers that are allowed according to this domain restriction. So we are going to include 0 So I really shouldn't have an arrow here, just pretend I'm going to put a solid dot. I just didn't want to change my arrow or my line type. But really that should be like a ray. It has an end point and then it shoots off forever going for numbers that are less than 0. So we include 0 because it says or equal to, and then we show all the numbers less than 0. So now my line fits with the way the domain is stated in the function. Now I'm only showing x coordinates that actually do have numbers. They represent numbers that are 0 or negative. Okay. All right. So moving right along, let's take a look at this second one. It says f of x equals 2x. Or, in more familiar terms, maybe you're used to seeing it as the linear equation y equals 2x. Means exactly the same thing. So, what would the line y equals 2x look like? Well, if we thought of this in terms of y equals mx plus b, the b is just 0. That means at the origin, I'm going to cross the y-axis at 0. And then from there, we'll count a slope of positive 2, up to right 1, up to right 1. And once again, I'm going to do the same thing. I'm just going to go ahead and draw this entire line, and then we'll come back and cut it off to match the domain restriction. Okay, so if all I was told was graph y equals 2x, then I would be done at this point. There's the line that is represented by the equation y equals 2x. However, this particular line only exists for these values in the domain. In other words, I can't have any x coordinates on this line that are not described in this way. Okay, for example, let me go down here and just pick a point right there. That is the point -3, -6. Okay, well, -3 is not in this range of numbers. Therefore, this point cannot be represented as being part of the line. I can only have x coordinates on this line that match the way they're being described in this function. Okay, so I hope you can see after doing our previous example that we're going to have to chop some of this line off. Okay, and let's do that. Let's chop this line off. Did it again. Sorry about that. Okay, I'm going to chop this line off so that it shows I have a little trouble with my tool here. I guess I'm going to have to say that's going to be close enough. Well, there we go. All right, and again, I really shouldn't have an arrow there, but just pretend. So how do I show only x's that fall between 0 and not including 0 over to 3? All right, so here's where x equals 3. So since I don't want to include 0 as one of my x coordinates on this line, I'm going to put an open circle at 0. For example, 0, 0, even though technically if I had extended it, it would be on this line, I can't allow that because I have to have only x's that are greater than 0. Like 1. 1, 2, that's okay. 2, 4, perfectly okay because 2 is between 0 and 3. I can even have the number 3 as an x coordinate on this line. So I just can't have any numbers beyond 3. So what I'm going to have to do is cut some of my line off on this side as well. Okay, and so now I'm showing the line that, and I will erase this mark. Now I have a line segment, and for every ordered pair on this line segment, they would have x coordinates that fit this description. Okay, so I hope you can see why we shortened the line to include just this little segment of the line instead of the whole thing. Okay, and we got one more. And we'll just go ahead and do this one in a different color. I'll choose this. If we pulled that out, it would say f of x equals 6 or y equals 6, whatever you prefer. Well, the line y equals 6 is again horizontal, crossing over the y-axis at 6. So I'm going to start off with that entire line. All right, but again, the domain is being restricted. So ordered pairs like, for example, -5, 6 aren't allowed because I only can use ordered pairs that have an x bigger than 3. So the line should not be going all the way this direction. We're going to have to shorten it. And here's how we do that. All right, and again, that arrow really shouldn't be there. Just pretend it's just a segment really that begins just to the right of 3. So it's placed just on the outside of this green dot because greater than 3 really applies to this. And then all the numbers to the right of 3, that's what greater than refers to, would also be involved. So as far as graphing each function, we just did that. Here's the graph of this piecewise defined function. And now let's state the domain. Okay, well for domain, remember domain correlates to x coordinates. Or you might think of the x-axis. I typically will just take my eyes and run left to right, just like the x-axis does. And then look at how the graph, if you put all of these pieces together, I know they're not connected, but if you just thought of them as just one single graph, ask yourself the question for domain. Are every single one of these numbers that are on the x-axis involved as ordered pairs? Whether that is the red line, the green line, or this brownish colored line. Is every single x being taken, being used as a x coordinate in the ordered pair? And it looks like they are, because this line goes forever that way. That's going to include every single x moving to the left, including 0. This green line takes care of anything from 0 to 3. And this brown line takes care of everything else to the right of 3. So we've just covered every single number there is. And so the way we state the domain in this case is the domain is x such that, there's our bar that reads such that, we have all real numbers. X, in other words, is any real number we could ever think of. Okay, now let's talk about the range. Well, if the domain were following along the x-axis, for the range now we're following along the y. And let me just make a couple of marks here. This graph, if we were to put it or compare it to the y-axis, it extends up to this point and it extends down to this point in total. Okay, it does not go above this line, which is y equals 6, and it does not go below this line, which is y equals -1. So for the most part, I'm using y coordinates that fall in between these two black marks, except for one little section right in here where I'm not using any y coordinates. We kind of skipped over a block of numbers between 0 and -1. Okay, so here's the way we're going to state the range. The range, y or f of x, such that, now let's go with this top part first, this range of numbers from 0 to 6. Those are all covered, but we're not including 0 in that range. Let's see the open circle. So here's the way I want you to show all the numbers between. We have 0 on the low end, we have 6 on the high end, and then we're just going to put f of x in between. Or if you put y, that would not be terrible. Now, notice because I'm including 6, don't forget I need to put or equal to. I did not do that here for 0 because open circle means 0 is not included. Now we're almost done. We've taken care of most of them, but remember we have this one single number down here because we jumped a whole block of numbers, but we have one more number that's identified as being part of the range, and it is the number -1. So we'll put the range together as this. The range is described as all the numbers such that they fall between 0 and 6, including 6. And then we've got this straggler number. The range is also including the number -1. Okay, that takes care of letter A. Now going forward, I won't draw the entire line and then erase it, but if you feel like you need to do that, that's certainly okay. Here's my letter B example. So I think I will go ahead and show you this in case this helps. I'll do this top piece in red, and if it helps, instead of saying f of x equals -x, just think of y equals -x. All right, so that has a slope of -1, y-intercept of 0. So here's my y-intercept of 0. Here's slope -1. Okay, but I'm noticing that I can only draw this line for x values that are less than -1. Well, here's where x is -1. Here is where x is -1 on my line. Okay, so at -1 on this line, I'm going to have an open circle. This dot can't even be placed because I can't use any x's that are not described in this way. So I'm going to go from -1 forever in the negative direction. And for this line, it'll look like this. Oh, I shouldn't freehand that. I'm going to get my line draw tool. Sorry, taking time. Maybe you're grabbing your ruler and change it to more of a ray because it only shoots off in one direction. All right, so looks good. Open circle at -1. I'll probably draw that a little long, but I think you get the picture. Okay, so we've taken care of this top one, and now let's take care of the one in the middle. And I'll just do this in blue. That means y equals 0, f of x equals 0. All right, so hopefully you're recognizing now when y equals a constant, that's just a horizontal line. And the horizontal line that crosses the y-axis at 0 okay, so here is where the y-axis, or the crossing the line at y equals 0, sorry, and that's literally the x-axis because here is where y equals 0. And so we need the line y equals 0, which is just drawing the line on top of the x-axis, but we're only going to draw it for this range of domain numbers, or these x coordinates. All right, so we have -1 on the left, it's like a left bookend, and we have +1 on the right, and we're going to draw a line between them. And we use solid circles because they both say or equal to. Alright, 2 pieces down, 1 more to go. Let's do this one in green. Okay, you can change this if you like to y equals +x. Well, if y equals -x started at the origin and had a -1 slope, well, this one does just the opposite. And now we're describing the domain as all the numbers greater than 1. Well, here is where 1 is, and the line is just going to continue on in its normal fashion from that point. So let me get my line ready, just an end arrow, and from +1, open circle. I had to color code it for you, so sorry about that. We are going to do this to represent the green. Okay, so we've got the graph, and now so let's get ready to state the domain. Alright, domain x, looking at the x-axis, looking above, are every single one of our x-axis numbers accounted for in this graph? Are you using every number from the x-axis to come up with ordered pairs on the red, the blue, and the green if you combined all of them? And I hope you see that the answer is yes, because the red is going from -1 forever left, the blue connects the two, the green goes from +1 forever right. So we've involved every single number that would exist on the x-axis. And so we'll state it this way: all x such that we have all real numbers. Okay, well now let's take a look at the range. Now we're looking vertically, and I hope you can tell right off that we don't have any part of our graph going down this way. We have no numbers from below 0 going downward, below less than 0, being involved in this graph. Okay, so that means that all of our numbers that are being used as y coordinates are from 0 upward, with the exception of this little space right here. We don't have any y coordinates being used between 0 and 1. Our graph doesn't go in that space. So here's the way we'll say the range. We're going to say any number from +1 forward, so f of x such that f of x is greater than 1. Notice I didn't put a solid, or I didn't put an underline because these are open. Okay, so that takes care of just about all the numbers in the range, and then we've got this one other piece that involves where f of x is actually 0. And we're done. So it's going to take you maybe a little practice, but you'll get used to seeing how to determine the domain versus how to determine the range. Okay, so here's another example. Let's take this top equation, and if you want to, I'll do it in red. Think of it as y equals 4 minus x. That's the graph of a line that has a y-intercept of 4 and a slope of -1. Okay, we can at least get some dots that we will look at connecting. However, we're only going to show the line that has x coordinates or domain members that are greater than 0. Alright, so I made these dots, but I'm not even going to need them, because greater than 0 is from this dot right. And I can't even keep this as a solid because it says greater than. It doesn't say greater than or equal to. So I'm going to go back up here and I'm going to make an open circle, and now I can connect these dots So, all right, so there's the red. And now let's do the other one in green. So think of it as y equals negative 2x minus 2. All right, so typically we would start at negative 2. We would do a slope of negative 2. All right, and we would draw this line forever and ever, but we have to keep this line so that it shows only x coordinates that are less than 0. Okay, so that means I can't even include 0. This dot right here, which is 0, negative 2, it can't be included because it has an x coordinate of 0, and it has to be less than. So we're going to show the domain being restricted to all the x values that are less than 0. Okay, and that takes care of the graph. And now let's see if we can work on the domain. Okay, so for domain, once again, you are looking this way. Are every single one of your numbers that would be listed on the x-axis going to be included in as ordered pairs if you put both of these graphs together? Well, almost everyone. Going to the left of 0, they're all taken, and for the red, going to the right of 0, they're all taken. The only number that's not taken is where we have this open circle, and that is actually 0. So the way we can state the domain, instead of saying all real numbers except 0, you can just do x such that x cannot be 0. It's assumed that it can be any other number besides 0. All right, so now let's look at the range. The range, again, we're looking vertically. Do we have all of the numbers that would be listed on the y-axis, both positive and negative, would they be involved as part of an ordered pair either in the green or in the red? If you put both of those together, I hope you see that from this point up, we're going to involve, let's do a different color. All right, so from this point upward, we're going to involve every single y value from negative 2 to positive infinity. Okay. Well, if you do that with the red, you're going to go from this point down, and you're going to involve every single y value identified by my red line going forever and ever. Okay. Keeps on going. Green keeps on going. We'll just think of it this way. Take the red and the green line and just make it one single line, and you're indicating every single number on the y-axis forever, both positive infinity and negative infinity. And so we state it like this. F of x such that it really is represented by all reals. Okay, so that's all I have as far as graphing piecewise defined functions. And now I wanted to show you how you can look at a graph and come up with the actual equations represented in the function. So let's take a look at that. It's just one function, but it's going to be our job to come up with really 3 different expressions to represent these different pieces. And I'll do these in a color-coded fashion. Okay, here we are at this red line. First of all, it's a line, so it makes it easy for us. We know we're going to come up with some sort of expression, y equals mx plus b. So we've done this a lot before. We just need the slope, and we need to know y-intercept, and if we know those two things, we can write the equation. We can tell slope pretty easily because we use rise over run. So if you just start at this point and you go up 1, left 3, that means the slope is negative 1/3. Good enough? We can't tell exactly what b is, but we can figure it out pretty easily just by using one of these ordered pairs. Okay, and for example, this is the ordered pair -6, 0. That means y is 0, x is -6, 0 equals 2 plus b. All right, I just found my b. b is -2. So now we're ready to write the piece, the equation that represents the red piece. And since we already have f of x, that's like saying y equals. We don't need to write that again. And so it would be -1/3 x minus 2. Okay, takes care of the red. Now let's take a look at the blue. Well, that's a horizontal line. Oh, I need to go back. Sorry, I didn't restrict the domain. If, on this red one, it's only true, this line only exists for x values, and hopefully you can see that, that are less than or equal to 3. Okay, it starts at -3 on the x, and then it takes in all the other numbers less than that. So, sorry about that. Forgot my restricted domain. Now we've got it finished for the red. Okay, let's take the blue. It's a horizontal line crossing the y-axis at 2. So that's the equation or the function f of x equals 2. But it's restricted also. For this, we're limiting the domain to numbers that are between -3 and +1. So I want you to write these between statements like this. -3 would be on the left side. We'll put x in between, and +1 will be on the right side. And since they're both open, we don't need to underline. Okay, 2 down, 1 to go. So now let's work on the green. On the green, once again, let's find the slope. So 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. Looks like the slope is 4/1, which is 4. The y-intercept, I can't really tell, but it's easy enough to figure. Remember, y equals mx plus b, y equals 4 times x plus b. So let's just pick one of these ordered pairs that we see. Really doesn't matter which. 2, 6. Means y is 6, x is 2. When we subtract from both sides, -8, we get b is -2. All right, so now we're ready to write that equation. F of x, that's already been done. The y equals has already been done. So we're going to do 4x minus 2. But now we're going to restrict the domain to numbers that are only 1 and larger. So we're going to say if x is greater than or equal to 1. Okay, and that completes that particular problem. That's all you have to do. Okay, I think I got one more of these. Let's see if we can knock this one out real quick. Our function is defined by these pieces. So we'll start with the red. Let's see, what kind of slope are we dealing with? 1, 2, 3, 1, 1, 2, 3, 1. That's a slope of -3. Pick one of these ordered pairs. 1, 2, 1, 2, 3, 4, 5, 6. -2, -6. And let's write the equation. Solve for b. Y equals mx plus b. -6 equals 6 plus b. -6 equals +6 plus b. And now when we subtract, I'm sorry, I just realized I wrote down -3 slope, and it should be +3, so I apologize for that. I didn't want to start this all over. We're too far in. So Sorry. Here we go. All right, so I think I've made the adjustment. Our slope should be positive 3. When we add 6 to both sides, we get a y-intercept of 0. Okay, so with a slope of 3, y-intercept of 0, this red line is identified by the equation f of x equals 3x, but only if this part is only defined for x values that are less than -1. Okay, so here's -1. -1 is not included because it's open, and so only those numbers for x that are less than -1 are defined. Okay, that takes care of the red. Let's do the blue. All right, that should look pretty familiar when you have a y-intercept of 0 and a slope of -1. That's the line y equals -x. Change my color. We looked at that one previously. That's the line y equals -x, but it's restricted in the domain. We have -1 on the left side and 1, 2, 3 on the right, and 3 is not included. So that takes care of the blue. All right, now let's work on the green. For the green, we can get the slope of down 1, right 1. That's a slope of -1. And pick one of these ordered pairs. It really doesn't matter which. You can take 1, 2, 3, 4, 1, 2, 3. So y equals mx plus b. Add 4 to both sides, and you get b is 7. So you put it all together, and you get f of x equals the slope, -1, x, and then plus the y-intercept, which we found to be 7. But this is true only if our values for x are greater than or equal to +3. Okay, here's 3. +3 is included. Okay, so that takes care of piecewise defined, and let me give you 2 more examples of these absolute value functions. We've talked about these before, so this is just to refresh your memory. They always produce V-shapes, so just think of the V in value. And your book doesn't really show you this method, but if you can just remember this little formula, I think it makes graphing these really pretty easy. So let me label, because we need to know what these letters M, B, and C all stand for. So the M, of course, is, think of slope. That's the number in front of x. In this particular case, the B, well, there is no B. B would be something inside the absolute value, either added or subtracted. And then the C would be something outside the absolute value, either added or subtracted. So the assumed B is 0, and the assumed C is also 0. So to get our vertex, pretty easy. We do the opposite of B, which is 0, over M, which is -4. Well, that's 0. And then C, also 0. So it looks like the vertex, this very bottom tip of the V, is the point 0, 0. All right? And from this vertex, I'm going to look at slope. Slope, again, is whatever is in front of x in this case. So I'm going to count both a +4 slope, up 4, right 1, up 4, right 1, and I'm going to do a -4 slope, because if I only do the positive, I won't have both sides of the V. If I only do the negative, same thing. So all I do now is grab my ruler and I connect those dots. off just a little bit. And there you have it. Find the vertex, use the number in front of x, and it's the slope both as a positive and a negative. Now, this one's a little different, and I'll show you why. We still find the vertex the same way. So let me label everything for us. The number in front of x is m, this other number inside is b, and the number outside is c. So we can find the vertex. If you know this formula, it's pretty nice. The opposite of b, which is -3, over m, which is 1, okay? And then c is 4. It says the opposite of -3. Well, the opposite of -3 is +3, and then +4. So let's go there. Make a dot. That's our vertex. Since the number in front of the absolute value is positive, I'm going to have a v that opens upward. Just for future reference, if this had been negative, then I would have a v that opens down. Okay, well here's where it's a little different than what we did before with this problem and previous problems that we've done with absolute value. When we have a number being multiplied times this absolute value, like this 2, notice we didn't have that over here. It's assumed to be 1. Whenever there's something like this in front of the absolute value, it affects the way you do the slope. Okay, so this is the only kind of tricky part of these absolute value problems where you're using this method of find the vertex and then count the slope. You can't just count a slope of 1. You have to treat it as a slope of 2 times 1. Just imagine multiplying those together. Okay. So, for example, let me throw a different one out at you. If I were to tell you to graph this, you find the vertex, M, B, C, use my formula just like I taught you. But then when it comes time to counting out the slope from the vertex, the slope is actually going to be 8, 4 times 2, both as a positive and a negative. Okay. So you got to be careful there and just multiply these together to determine how to build the V from this vertex. All right. So that's going to come up a couple of times in your homework, I believe. So let's go ahead and finish this problem off. So now I'm going to count a slope of +2. That's up to right 1. And we'll do that one more time. And then I'm also going to do -2 because obviously I've got to do both the positive and negative to get the V shape. And so here we have our absolute value function. All right, and that is it. And I gave you the assignment, and I hope you work hard on this. If you have any questions, let me know. There should be some homework help videos available, so check those out. And if you have any questions, either email me, come to academic support, or bring them to class with you on next time.